Good morning, students. Today I am starting the class 11th physics. In this physics, first chapter is the physical words. Student, this chapter is the so easy because you have learned in the previous classes. And second chapter is the units and measurement. Second chapter is the units and measurement. So I am discussing this chapter units and measurement. So student, I am discussing the units and measurement. First point is the unit. How to define the unit? What is unit? What do you mean by unit? Every physical quantity, it can be expressed by the standard. This standard known as the unit. Example like that the SI unit of velocity is the meter per second square. Acceleration equal to meter per second square. These. Now we are discussing about the type of unit. There are three types. There are various types of unit. First is the CGS. Second is the PS, or third is the MKS, and fourth is the SI. C for centimeter, C stand for centimeter, G for gram, or S for second, and up for foot, up for watts foot, P for pound, or S for second. Still in this case, 1 foot equal to 12 inch, and 1 inch equal to 2.54 centimeter. So it's become the 12 into 2.54 centimeter equal to 30.48 centimeter. It's mean the 1 foot equal to 30.48 centimeter. Pound, 1 pound equal to 454 gram. And as in the second, it is applicable for the time. Okay. Third is the MKS. M for meter, or K for kilogram. M for meter kilogram, and this for the second, applicable for the time. Students, fourth is the SI. Lots of students are telling, sir, system of international. No, it is proper way, international system. What's international system? So these are type of the units: CGS, PS, MKS, and SI. SI, what is the full form of SI? International system. Okay. And we are discussing about in this chapter, most point important is the dimension. So student, first define the what is the dimension. So power of the fundamental unit is called the dimension. Either you can say power of the fundamental unit to be raised is called dimension. So I am discussing the first point is the dimension, and how to write the dimensional formula of the given physical quantity. Suppose that you have given the various types of formula, I write the dimensional formula. But before writing the dimensional formula, students, you remember the one thing is this: power of the fundamental unit. Power of the fundamental unit raised to be called dimension. So power of the fundamental units, here is the one point. What is point? Fundamental units. So there are the 7 fundamental units. First, watts, mass. Second, length. L. Third, time. T. Fourth, temperature, means Kelvin. Fifth, electric current, ampere. Sixth, luminous intensity, expressed in candela, means CT. And 7, amount of substance, means mole. These are the fundamental units. How many fundamental units? 7. Mass applicable for m, length applicable for L, time applicable for T, temperature applicable for Kelvin, means K, and current applicable for A, luminous intensity, candela, or amount of substance, the moles. And 2 supplementary unit. What is the supplementary 2? First is the plane angle. It is measured in radian. Or second is the solid angle, means stay radian. It is applicable for the solid angle. Radian or steradian, both are the 2 supplementary fundamental unit. Okay. Now I am starting the how to write the dimension. Example. Suppose that you have write the dimension of length. Okay. Length, it is 10 for L. So dimension formula of the length is the L. Second, area. What is the formula of area? Length into breadth. Is 10 length for L, breadth for also L. So how many power? Power is 1 and 1. It's become the L to power 2. And it's from the m to power 0, because here mass is no, and L means L to power 2, time is no, so its power is the 0. Either you can this form, either you can write this form, both are same. And third number, volume. What is the dimension of volume? You still know that length into breadth into height, means length for L, breadth for L, or height for L, means 1, 1 and 1, it's becomes the L to power 3. So dimension formula is the L to power 3, and you also write on this form, m to power 0, L to power 3 and T to power 0. Student, one thing is a very important thing during this case. Lots of students are telling the area dimension of the area L square. No, not L square. It is a power of the L to power 2. So, because your definition you have given the power of the fundamental unit. The power of the fundamental means what is this? Not square. This is the power of the L to power 2. So you should written as you are told as L to power 2, and here is L to power 3, not L cube. L to power 3. Point number 4. Suppose that you want the velocity. So first, before writing the dimension formula, student you should must write the what is the velocity. What is the formula of the velocity? The displacement upon time. The displacement of what is the displacement means length, time for t, then it's become the ulti inverse, or either you can say m to power 0 ulti inverse. Okay, this is the dimension formula of the velocity. Now momentum. What is the formula of momentum? Momentum equal to mass into velocity. You know that mass into velocity. The mass it is applicable for m, and velocity is applicable for what? Ulti inverse. So it's become the what's m ulti inverse. This is the dimension formula of the momentum. Next is force. Force equal to what is the formula of force? Mass into acceleration. Mass into acceleration. So mass stands for what's m, and acceleration stands for what is acceleration? Acceleration means velocity upon time. Okay, so what is the dimension formula of velocity? You know that ulti inverse. Okay, put this value ulti inverse upon t. It's become the ulti inverse 2. This is the dimensional formula of the acceleration. So dimensional formula of the acceleration is equal to watts. Then it's become the watts m l t inverse 2. This is the dimension formula of the force. Students, during this case, if you write the dimension of any physical quantity, so first you write on the what are the formula, appropriate formula, what are the formula of this physical quantity, and they can write the dimension with the help of the fundamental units. So we are discussing about the dimension of the formula of the force. Now I am discussing about the what is the formula of the kinetic energy. What is the dimension formula of the kinetic energy? Question first, we should write down the what is the formula of kinetic energy. You know that kinetic energy is equal to half mv square. One thing is the important thing is students. Here is a half means constant. All constant are dimensionless. It means that it has no dimension. All constant are, and formula of the kinetic energy half mv square stands. Here is the half means constant. All constant are dimensionless. It means that it has no dimension. So m stands for this, and v is the velocity. So what is the dimension formula of velocity? You know that ulti inverse, and this is the m, and it's become the ulti power 2 t to power minus 2. This becomes the m ulti power 2 and t inverse minus 2. This is the dimension formula of the energy. Next, work. So what is the formula of work? Force and displacement. Force and displacement. So still you know that what is the dimension of force? M L T inverse 2, or displacement for L. Means this is the M power 1 and power 1. It means the L to power 2 or T inverse 2. So this is the dimension of the work. Now work equal to energy. So dimension from our same watts m to power 2 t inverse 2. This means one thing, the important thing, kinetic energy, work or energy, various types of energy, but dimension formula are same. Okay, next point is this. Next formula is this. If you want, suppose that you want what is the dimension formula of surface tension. What is the dimension formula of the surface tension? No problem. What's surface tension? surface tension. Formula is this: force per length. Student, you know that the dimension of the force watts ml, T inverse 2, length 4, L cancel, so m T inverse 2. So this is dimension of the this is dimension from the surface tension. Okay. Next, the force constant. These are the most important question. Force constant. Force constant means also force per length. Dimension of force, you know that, and it is divided by L. So it's become the mt inverse 2. So surface tension or force constant, but dimension formula same. Okay. Next point is the gravitational constant. This is the gravitational constant. Student, know that G equal to watts half into R square and M1 into M2. This is the universal gravitational constant. G equal to the dimension of force students, united M L T inverse 2. Okay. R for distance means L to power 2, and mass, two mass, one mass is M and another is the M. So mm cancel, and m to power 1, L to power 1 and L to power 2, it means L to power 3, T to power minus 2. So this is the dimension formula of the gravitational constant. Okay. Next point is the, suppose that you want the Planck constants. Dimension of the Planck constants. Planck constant means mu equal to energy upon frequency. Energy upon frequency. Energy upon frequency means, you know that the dimension of energy watts. You know that the dimension of energy m L to power 2 T to power minus 2, and frequency. Frequency equal to, you know that student, frequency equal to number of vibration or number of person is T inverse. So it's become the T inverse. Then watts m L to power 2 and this T to power minus 1, because this plus 1 at minus 2 plus 1 becomes the minus 1. This is the dimension of the Planck constant. Still one thing, if you write the dimension of the any physical quantity, first you should write down the formula, then you have write the dimension, you have no problem. Okay. Now I am discussing the dimensional formula. What is the dimensional formula? What are the uses of the dimensional formula? And the limitation of the dimensional formula. This question is a very important question for you. First, how to define the dimensional formula? What's dimensional formula? Dimensional formula and its uses and limitation. First student, I am discussing the dimensional formula. Student, write down every physical quantity expressed in dimension. So you can say dimensional formula. Every physical quantity it can express in dimension. So it is called the dimensional formula. Example, velocity of dimension, a dimension formula. You know that velocity equal to what's displacement by time means L T inverse 1. And acceleration, what is acceleration? The velocity upon time, the L T inverse upon t means it's become the L T inverse 2. This is the dimensional formula of the this physical quantity. Now I am discussing the usage. These are the most important point. Usage of dimensional formula. Usage of dimensional formula. What is the usage of dimensional formula? First, to check the first to check the any physical quantity, any physical quantity, or you can also correctness of formula, correctness of formula. Example, I am giving the one example. Suppose that you know that v equal to what, u plus at, where v is the final velocity, use the acceleration, use the initial velocity, a is the acceleration, t for the time. Instead, in this case, LHS, what is v? V for velocity. So instead, you know that the velocity of dimension of velocity what's RT inverse. Okay. RHS, what's RHS? U plus AT. U is the initial velocity, so dimension it will be also same, means RT inverse. A for acceleration means RT inverse 2 multiply by what's t power 1. It means the RT inverse power plus 1 and minus 1 means RT inverse, means twice RT inverse. So instead you have seen what's LHS equal to RHS. LHS equal to RHS because dimension of LHS equal to RT inverse and RHS equal to twice RT inverse. So what is 2? 2 is the constant, so dimensionless. So you observe the RT inverse, LHS RT inverse and RHS also RT inverse. So this is the important formula. You can write the any formula and check with the help of the dimension. Student, I am explaining once more. V equal to u plus at. The v for velocity dimension of velocity RT inverse, and u for initial velocity, so your dimension is RT inverse. A for acceleration dimension is this, and t for this. Power is plus 1, here is a minus 2, it's become the RT inverse. So it's become the RT inverse plus RT inverse, it's become the 2 RT inverse. Student, you have seen the LHS and RHS, both side dimension are same. RT inverse and here is the 2 RT inverse, means 2 is the dimensionless, you know that. So dimension formula same. So during this case you can say this formula is the correct. Okay. Student, I am giving the another example. Parts. Student, you know that S equal to ut plus half at square. Ut plus half at square. Okay. LHS as for distance, it is applicable for L. Okay. RHS, what's ut? Okay, half at square. U for initial velocity, you know that the dimension of initial velocity RT inverse multiply by t, and half is constant, so dimensionless. A for acceleration means RT inverse 2, and t square means this is the t to power 2. T to power plus 1 and minus 1, it's cancelled. Here is L, and t to power t square and minus 2 means cancel, it's become the twice. So students, you have also observed the RHS equal to what's L and RHS equal to what's twice L. Both sides are dimension formula are same. You can say this formula is correct. 2 is the dimensionless, so you have seen the this and this. Okay. This is the another example. Half mv square equal to mgh. Now for student, you have given the LHS parts half mv square. So you should write on the dimension. Half dimensionless, m for m, v for velocity means RT inverse square. It's become the m L to power 2 t to power minus 2. Okay. RHS equal to what's mgh. M for mass, A for acceleration means what? T inverse 2, or as for heights it become the L. So students, M L to power 1 and 1 it's become the 2 T to power minus 2. So students, you have seen that this equation RHS equal to RHS, it is also correct. I am giving the one example more. T equal to time plate equal to 2 pi under root Ly. Student, LHS watts T for time, this is the T. RHS watts means 2 rise by under root Ly. 2 pi is constant, no problem. L for L or G for acceleration due to gravity, L inverse 2. LL cancel, distance root, and it's become the T square. Then root of T square equal to T. So students, you have seen the words LHS equal to T and RHS equal to T. Means both physical quantity is also correct. This is the lots of example. I am giving the lots of example factors of the physical equation. Okay. Students, I am giving the more example and more important questions we will discuss. So you should must subscribe the my channel. Okay.